Hello, you're watching an introduction to vCloud networking. Now, this will probably be the most complex lesson within this course just because networking in vCloud is quite difficult. It's the glue that holds together pretty much the entire vCloud. The cloud is all built upon the networks that tie their virtual machines together. And the real underlying goal of vCloud is that you kind of do a design one time, you make this repeatable design, and then a consumer can come in and provision off that design, and you don't have to go and rework the networking. Now, I'll say anything that you have to design where it'll just be used over and over again without having an admin interact with it innately becomes just more difficult because you have to design for all those variables. So networking is quite a challenge. Now, I'm going to kind of break it up into different pieces and try to make it as easy to swallow as possible. But don't feel bad if it takes you a little while for this stuff to sink in, because frankly, the networking piece, again, is the most challenging part of vCloud Director. So like I normally do, we'll go over the lab design and what's going to be touched in this lesson by using my creative little red arrows and red box. Now, as you can see in this slide, I've got the vCloud Director cells will be manipulated through this lesson because that's where we're really going to do all of the defining of the rules and the networks and logically creating these networks, as well as the vCNS manager, the vCloud Network and Security Manager, which will also be termed as the vShield Manager, because the vShield Manager is going to kind of play a smaller role in this environment in that it's going to provide the vShield Edge devices or vCNS Edge devices, which we'll use for fencing and routing and doing NATing and a couple different things. But they're kind of on a case-by-case basis. Sometimes we'll use an edge device, sometimes we won't. It really depends on the network that we're building. And then the next thing is the vCenter server that's managing the cloud environment, because that's actually where the network lives. That's where the logical networks have been defined and where the actual switching is taking place. And then finally, I've drawn the red box around the vSphere resource cluster because that's where the activity is actually going to take place. When we do these different designs on the network and apply them, they actually live in the resource cluster. So that none of the networks that we define are anywhere in the management cluster. It's all defined there and then applied in the resource cluster. So let's move into the various different types of networks that are available in vCloud and go over how they work and what they do and some kind of real-world cases where you may want to use one over another. So to start with, we have external networks. And if you think about cars on a racetrack, they just go round and round in a circle. Think of that as the vCloud environment. Everything's kind of contained within that racetrack. The external network is how you get out of the racetrack. Now, hopefully you're not sitting in the stands and someone decides to just plow their way through the stands, because that would be painful. But to think of, that's how you leave the racetrack. You take this external network and it allows you to leave that environment. Now, I note that that doesn't necessarily mean internet access, because typically I think of external access as that's how I get to the internet. That's external to my environment. That's not what this means as a rule. It could go to the internet, but it could also just get to your corporate LAN, which then gets you to the internet. So by external, all we're really saying is that this is the network that gets you out of the cloud and to wherever it needs to go after that. You pretty much have to define an external network because, again, like I alluded to earlier, if you just have a network that can talk to itself and not to anything else, again, it becomes kind of pointless to a degree, unless that's exactly your use case, which would be odd. I've not seen that where you just want this self-packaged network that only talks to one another. So you're pretty much always going to need an external network. The real decision point is going to be, is that a corporate LAN? Is that a co-located LAN? Is that the internet? It really depends on your use case. A lot of times, though, in the real world, an external network will simply translate to the LAN in the corporate environment. So moving to the next type of vCloud networking, we have network pools. Now, network pools are really how we decide exactly how we define these different types of networks that will be used by the organizations and the vApps and things like that. It pretty much boils down to 4 different types of network pools. And it used to be 3 types back in the old days, but now that we've got some new fancy network tools, we can provide 4 different methods for making pools. So I'll go over them in the order that they're listed. The first is the vSphere port group backed. It's kind of a mouthful. So it kind of has a descriptive name. You can kind of visualize vSphere port group. That's where we're going into the cloud environment, the vCenter server that's running the cloud, and we build port groups ahead of time. So you may go into your vSphere environment and build out port groups for production and maybe databases or development, things like that. And you've built those port groups ahead of time. And then when you build a network pool out, you direct it to those port groups. You tell it, I made this production port group and I want you to use it specifically. Don't do anything else other than use this port group. And here's the IPs that go in that port group. And vCloud Director salutes you and says, yes, sir, right away, I will do that. Or yes, ma'am. This is probably the most rigid and static and kind of non-cloud-like networking because you're having to provision it all up front and there's no way to really automate that after the fact. You either build it now or maybe you automate the building of it later, but vCloud itself can't build it on its own. You're not letting it. The only real time I see this used, in a common scenario would be if you just have some kind of security requirement where port groups have to be provisioned by an admin. Maybe there's a RFC or request for change process that just limits you to this. You may just be kind of stuck with a constraint in that your design is limited to a person pulling the lever and building the port groups. But we really want to try to avoid using that. The other reason you might use it, I suppose, is you need to use a regular virtual switch instead of a distributed switch. Because this is really the only way you can get away with using a standard switch is by using port group backed. The next item on the list is VXLAN backed. And that sounds cool, right? It's got an X in it. It just sounds neat. It's the virtual extensible LAN. And I can almost imagine this guy walking in with a cape and some boots and everything and being, I'll save you. I'm the network guy. So VXLAN is kind of the new kid on the block as it relates to the other technologies on the list here. And it's an overlay transport technology. That sounds fancy. Basically just means we're going to take our layer 2 and layer 3 network and we're going to use it to help build a stretched layer 2 network. So let's say you've got disparate layer 3 networks. You've got a 10.0.1 and a 10.0.2 network. Those are two different layer 3 networks, but you want them to appear as a 192.168 network. VXLAN can help you do that because the layer 2 frames, Ethernet frames, are kind of hidden underneath the layer 3 network. So you're able to kind of transparently make virtual machines think that they're in the same subnet when they may be different parts of the data center or completely different data centers altogether. And now, there could probably be a whole course on VXLAN. It's a little bit complicated to wrap your mind around. It requires multicasting, which basically means you're using IGMP, querying and snooping, and a lot of fancy terms. We're really not going to touch it that much in this course, but you should be aware that A, it exists, and B, it's really being pushed pretty heavily as we go forward. So when you build out a vCloud Director environment, it's just going to automatically create a VXLAN network pool for you. You don't even have to ask, it's going to do it. So I'm getting the feeling that this is going to be preached a little more than traditionally. But again, it is quite advanced, and realistically, I'm not seeing it that much out in the field just because of the newness of the technology and the fact that the multicasting is kind of a unique requirement that can be difficult to achieve in a lot of corporate data centers. Now, the third one is VLAN backed. And now we're starting to get probably a little more in the comfort zone. VLAN is something you've at least heard of, and a lot of network guys are going to give a thumbs up like, oh yeah, VLAN. I know VLANs, no problem. And it's a lot easier to sell the idea of a VLAN to your internal team. Like, hey, you guys want to use VXLAN or VLAN? They're going to say, well, I don't know what a VXLAN is, so let's go with VLAN if you had to compare the two. Now, what VLAN back does is you basically tell vCloud Director, hey, I've got these VLANs, and I want you to use them as you need to. So let's say you said, here's VLAN 500 through 599. Those are yours, and whenever one of my tenants needs a network, go ahead and grab one of those VLANs and use it. And it's automated, which is kind of nice. And in a lot of private environments where you're not using a whole ton of VLANs, it can be very easy to use because you don't really care if it's going to use 100 VLANs or not for your private enterprise. those VLANs are yours to use or not use anyways, and you get just over 4,000 VLANs before you run out of them. So for a private enterprise, I doubt you're anywhere close to 4,000. You probably have thousands of VLANs left over. So this can be a good way to do a simple deployment of the network. So the final one is the vCloud Network Isolation Backed, or vCDNI. Now this has been a more traditional way to set up an encapsulated network. It is a way to do an overlay network, I should say, where we can use special identifiers in order to help isolate different pieces of the network. It requires just one VLAN. It really doesn't even require it. It'll use VLAN 0, which is kind of none if you don't have one. I typically recommend a VLAN just for security purposes. And it's relatively easy to implement. You don't need multicasting. It does require a little overhead in the Ethernet frame, but really that's about it. So it can be a lot easier to use than VXLAN, has less requirements. It's also quite scalable. Just like VXLAN, although VXLAN you can get thousands and thousands of networks out of it. vCloud network isolation networks are limited to 10 network pools per vCloud instance. So you get less pools, unlike the VXLAN, right, where you get 10,000 pools. But that may be okay. So the only thing I want to kind of conclude with on the network pools is, other than the vSphere port group backed network pool, all the other network pools requires a distributed switch. And realistically, you're going to have, at the very least, enterprise licensing to do vCloud because it requires the use of DRS, Distributed Resource Scheduler. But realistically, you're going to have Enterprise Plus most likely, because not having a distributed switch really kills a lot of these networking constructs that you see here. So that's why you're pretty much going to have to choose a distributed switch anyways. I don't really see anyone doing standard switches, but just to be clear, you can use a standard switch for the vSphere port group backed. Everything else requires a distributed switch. As a word of caution, if you're going to use either the VXLAN backed or the vCDNI, which is the vCloud Network Isolation backed network pools, you'll want to enable jumbo frames. This is kind of a weird set of words, jumbo frames, but basically all that means is that we're going to increase the maximum transmission unit, or MTU, to be larger than the standard 1500 bytes that it's normally capped at per frame. So even if you made the MTU 1501, you've technically made a jumbo frame. A lot of people associate the word jumbo frame with a 9000 MTU, which is typically the maximum size that you can make the transmission unit. Some systems will let you go a little larger than that, but 9000 is kind of a standard. This is a jumbo frame. In reality, it's just anything larger than 1500 is really a jumbo frame. So to use these different types of network pools, VMware advises that you go ahead and increase the MTU on all your network gear to 1600 MTU or larger. You could just go ahead and set it to 9000 and be done with it if you wanted. So that means the VMware, the VM kernel ports, the physical switch ports, etc., everything from source to destination needs to have its MTU adjusted to 1600 or larger. Otherwise, you'll get what's called IP fragmentation. And this just means if it can't fit the entire payload into the MTU size of the frame, so let's say you're trying to send 1600 bytes of data, but your MTU is set to the standard 1500 bytes of data, there's 100 bytes of data that won't fit. So it's going to have to fragment that IP packet into two, one containing 1500 bytes of data, another one containing 100 bytes of data. And as you can imagine, that's inefficient. It basically means you're going to have to send two packets when one would really do the job. And in some cases, if you have a router or switch that specifically will not fragment the packets, you could end up in a situation where the network simply drops the traffic and you're getting all sorts of errors. So with those types of network pools, go ahead and set the MTU on your network equipment to 1600 or larger. And don't forget to set the size of the MTU on your distributed switch as well, as that is technically a piece of networking equipment that's within the stack. All right, so now we're getting into a bit more of the fun plumbing. With the network pools, we're really figuring out how we're going to get the traffic from A to B and how we're going to define the VLANs and things like that. And And that, that isn't all the most fun stuff to do, to be honest with you, setting up networks and pools of IPs and such. To me, the plumbing is a lot more fun. And this is where we get into the realm of organization VDC networks. Now, org VDC networks, as we're going to call them, pretty much is limited to 3 different types. You've got external direct, external routed, and internal isolated. Now, I find that the use of the word external can sometimes cause confusion because we already talked about an external network. So now we have an external org VDC network. That's kind of confusing. So the real kind of reason for that is anything with the word external for an org VDC network means it's talking to the external network. That's it. Org network talks to external network. So we call it an external org network. And I'll show you some examples and we'll go over these 3 different types. So I've got some graphics here that came out of the vCAT from VMware to help kind of explain visually what we're talking about here in this lesson. So the topmost graphic is a direct connected org VDC network. It's an external direct network. And as you can see, we work from left to right. The virtual machines within the vApp can talk to the org VDC network, which then directly communicates with the external network. There's no router, there's no NATing. It's just a direct connection straight from the org network directly to the external network. And that also means that the IP structure set up in the external network will have to be used by the vApps as well, because we're not doing any NATing, we're not doing any routing, and we're not doing any masquerading or proxy ARPing or anything special. It's just a direct pipe that we're plugging directly into the external network. The next use case is external routed. So the external routed looks a lot like the first network, like the external direct, except we placed a vShield edge device in the middle of the two. And we've also got 2 different subnets now. We've got the subnet of the org VDC network and the subnet of the external network, and those are different. The routing device will provide things like DHCP, firewall, VPN, and NAT services to the vApp, to that organization VDC network. So it's providing some kind of value add to the org VDC network that you need for your vApp. Because based on your design, you've got the edge device in there for some reason. Maybe you just have it there because you want to have IPs assigned. You're using the DHCP feature to provide IPs to your vApp because you don't want to exhaust the IPs of your external network. Because you can imagine, the external network may only have a small, limited number of IPs available. Let's say that you're consuming this cloud and you only have 10 IPs available. Well, you don't want to consume all those by your VMs in the vApps. You'd only be able to have 10 VMs. That's not enough. So you could throw in some routed org VDC networks to give out DHCP addresses and then NAT it out to the external network. And it's just like your data center now or your computers now where you may only have one WAN address in your lab environment, but you use NAT in order to have multiple computers on your network and your tablets and laptops and all that good stuff. Very similar concept. So the final different design, you see it in the bottom left corner there, is the isolated org VDC network, the internal isolated network. And this one's kind of lonely looking. It doesn't go anywhere. The VMs in the vApp talk to the org network, and that's pretty much it. They can talk to each other using that org network. And if any other vApp was tied to that org network, they could talk to the other vApp, but they're not leaving the org network. You can see there's no external network that they can even get to. So this use case is a bit more used for perhaps you need an application that's only talking amongst itself and you want to see how it performs when some test occurs. I see this a lot for like a pre-production environment where maybe you want to test a database server that's talking to an application server just to see what happens, and you could throw it on an isolated network to make sure that it doesn't impact anything else in your environment. So the final type of networking in vCloud is vApp networks. Now, vApp networks are interesting because when you build a vApp, that's kind of when you decide how the vApp network should work. And they're kind of on demand. When the vApp is powered on, this network kind of exists and is functioning. And when it's powered off, the vApp network is not needed. It can be, kind of shelved, so to speak. It's powered off. So unlike an org network, which is kind of always sitting there and available and ready to go for any vApp that needs it, the vApp network kind of has an on-off switch to it. And it's the most complex of the list because it has 4 different types of operation, different modes of operation. So a real quick rundown on these 4 different types are direct, fenced, routed, and isolated. And I think after you see how these work, the words and the names will really click. The problem with vApp networks is now we're starting to get really complex because a vApp network talks to an org network, which talks to an external network. And based on how the org network is set up, it kind of changes the behavior of the vApp network, so to say, so that perhaps you have a NAT device in the org network that talks to the external network, and then you have another NAT device between the vApp network and the org network. Now you're doing double NAT. So it's not just that you're creating the vApp network kind of on its own. It also then has to talk to the org network and potentially the external network, depending on how you set it up. So you can have all sorts of use cases. I mean, you can really get fancy with these things. We're going to keep it simple. I'm just going to go over some very basic use cases for these to help start your noodle kind of boiling a little bit on how these work. So again, I have some examples of vApp networks in front of you, kind of like we did with the org networks, and we'll work top to bottom. So the first example is the direct vApp network. And I've included the whole stream. Again, these are from the VCAT that you can look at anytime you want. They're courtesy of VMware. And so the first example is the direct network. Anything direct is always really easy to visualize because there's nothing in between the different networks. The virtual machines within the vApp talk to the vApp network, which is directly connected to the org network. And I'll stop there because at that point, the vApp network being direct is doing what it said it's going to do. It's a direct connection to the org network. The org network then could be any of the other 3 org networks that I talked about previously. It could be a routed or direct or isolated org network. But from the vApp network's perspective, it just needs to directly connect to the org network. That's all it needs to do. In the example I show you, the org network is also directly connected to the external network. So there's only one subnet for the whole thing. Everyone's using that 10.1.1.x subnet. Very easy to visualize, but not necessarily very common, because at this point you're building all these networks, and it may be used for something, but I don't typically see it where you've got just everything plumbing all the way to the external access in such a fashion. So think of this more as a learning guide and not so much as reality. The second design in the middle is the fenced vApp network. And this is where it starts to get very useful and very interesting. The fenced network basically means that it's a method in order to protect the identity of the virtual machines. And what do I mean by that? So let's say one of your developers comes up to you and says, hey, Mr. Admin or Mrs. Admin, I need to build out 3 copies of the same vApp because I'm testing 3 different bug fixes. And I don't want to test the bug fixes all at the same time because then I won't know which fix cured which bug. So I need 3 identical vApps with the same IPs, the same names, all that kind of stuff. Can you do that for me? And typically you'd say, no, I can't make 3 identical applications with the same IP and the same name. You can't do that on a network because then how would the packet know which VM to go to? I can't, no, you can't do it. That's where fencing comes in. So the main goal of fencing is to allow you to do something like that. You could have 3 or any number of vApps all hidden behind a fenced network. The edge device then performs isolation duties. So it's really just doing what's called a proxy ARP, or address resolution protocol. In that, let's say the IP of every VM in the vApp is 192.168.1.1. Or we'll even use the IP that they show here, the 10.1.1.x. So if they all had 10.1.1.1, then the edge device may assign them a 2, a 3, and a 4. They all think that they're 10.1.1, but in reality, the edge device is making sure that if you want to talk to the first vApp, you use a 2, and the second vApp, you use a 3, and the third vApp, you use a 4. So it's kind of hiding the actual IPs behind some pseudo IPs, we'll say, some different IPs. And that way, you could go back to the developer guy that asked for the virtual machines and say, yeah, the first vApp is under that 10.1.1.2, the second one is under 10.1.1.3, and the third one is 10.1.1.4. He knows the IPs that you've given him, but the apps don't. So it's a way you can kind of hide behind this special proxy ARP process. If you've ever used VMware's Lab Manager product, this was a big strength of that product because it did this fencing. The next design at the bottom is a routed network. It's very similar in look to the fence network, except it's doing different things. The virtual router there in the edge device sits between the vApp network and the org VDC network. Its basic purpose in life is to provide some services for the networks in there. It provides a new subnet, it provides some routing, provides NAT, firewall, things like that, so that the vApp is kind of in its own different world, its own subnet behind the edge device. And then past that point again, the org network could be direct to the external, as I show you in the bottom example. It could be isolated. It could be routed. It could be anything at that point. We're just focused on that relationship between the vApp network and the org network. And in this case, it's a routed network with an edge router in the middle. The final example on the top is an isolated vApp network. And that one's super easy. The VMs can pretty much talk to themselves within the vApp. That's it. Doesn't go any further than that. In this example, these 4 VMs can talk to one another through that isolated vApp network and no further. Now, the first question that enters my head when I see that is, what is the point of that? Why would you ever want a network that doesn't go anywhere? And that's a good question, but it's a little more common than you might think. So let's go back to an example where we have a 3-tier application. Web server talks to app server, and app server talks to database server. It's a very common configuration for the 3-tier app model. Now, what you don't ever want to happen is having the web server talk to the database server. Web talks to app talks to database. That's the pattern. So what you might do is put the app server on an isolated network directly to the database server so that they can only talk to each other on that isolated network. And then you might build another one where the web server talks to the app server on a different isolated network. And that way you've ensured that the web server can only talk to the app server and the app server can only talk to the database server by using a pair of isolated networks. I'm not saying that's the only way or the best way to do it, but it's definitely something that I see used. So just to kind of throw a little bit of complexity at you, just to show you how crazy this can get, I copied the image of kind of a very complex looking network at the bottom, in which we have a routed vApp network talking to a routed org VDC network, talking to an external network. So there's actually 3 subnets below there and 2 NAT domains. So the 192.168.1.x network is then natted to the 192.168.0 network in the org VDC, which is then further natted to the 10.1.1.x network for the external network. It can get crazy, and this is what I'm talking about, where it gets really complicated, because trying to put all this in your head and learn it when it's at that complexity, it's just too hard. You shouldn't start with something that complex. You really want to start with those 4 basic direct connected examples that I talk about and branch out from there, especially when we start throwing these 3 networks at each other. And this is just one vApp. Imagine that you had 30 vApps all talking to different vApp networks and different org networks. Like I said, you kind of need a giant whiteboard and markers and stuff to draw all this out, because it just gets really, really complicated very quickly. Unless you're just in the ground floor on the design helping them do it. So rather than using just the VMware examples, I went ahead and kind of threw together kind of an example of an enterprise vCloud networking, model, in which we have 4 virtual machines within 2 vApps. So the vApp on the upper left in the blue has 2 virtual machines, and the other vApp, also in blue, has 2 virtual machines. So the first vApp with the 2 virtual machines in the upper left has a red vShield Edge device that is talking to an internal org VDC network. So that's an isolated internal network that doesn't go anywhere. The second vApp on the upper right has a direct connection to a external org VDC network, which then goes to the external corporate network, which also goes to the physical network. In between that upper right vApp, it also has an internal isolated vApp network. So you got all sorts of cool stuff going on here, and we're starting to see. I hope I'm showing you scratching the surface of how interesting and complex and kind of messy it can get if you start going hog wild with all these different network designs. And you may have use cases for all this, but it doesn't make it any easier. You'll really have to document this well and plan it out very well and build it all, with a lot of thought put into it. This isn't something where you just next finish, throw in some IPs and call it a day. You really got to spend a lot of time figuring out how you want to build this so that the consumers of your cloud can just click a button saying, yeah, I want another one of those. Give me an app server, poof, and it comes right out. And the networking just materializes. Like I said, it takes a lot of ingenuity to build a network where just a consumer can click a button and it scales. Okay, so now that we're done with all that fun lecture that I'm sure you just absolutely loved, let's go into the real world environment of my non-real world lab. And I'll show you some examples using these different networking types that you just learned about. Okay, welcome to the lab version of the vCloud Director. And I've logged in and I'm at the Manage and Monitor tab, which is right here. So there's pretty much nothing configured at this point. The external networks are empty and there's only one network pool, and that's that default VXLAN network pool that gets built when you first deploy a provider VDC. So we didn't build that. When you're building out your lab, you'll notice that it's the name of the provider VDC -VXLAN-NP. That's just the standard build for that name. We're not going to touch that, but I just wanted to point out that it's there. So let's go back to the external networks and build out an external network for the lab. So all you got to do is hit this little plus button right here for Add Network, and then select the vCenter server. And I've built a port group out called External Access on the vSphere environment. It's currently set to VLAN 0, which means no VLAN, because it's going to an untagged environment in my corporate LAN, which is basically my home lab LAN. You can change the VLAN in your lab to match whatever VLAN you're using, or you can do like I did and just use 0 if you don't have a VLAN set up. By default, it says these provider VDCs will connect to this new external network. The list there is gold because that's the only one that we've built so far. So there's no even choice for that. It just goes to the provider VDCs and you don't even get to say yay or nay on that. But it needs an external access anyways, so it's going to use this one because it's going to be the only one that we have right now. Click Next. And then we'll configure the external network. So right now there is no external network, and we need to give some IPs that can be used by objects and networks that need to use the external network. So we'll click Add, and I'll put in my information for my corporate LAN. You want to do the same for yours. So mine's 10.0.0.200. It's a class C, which is 3255.0. Put in my DNS server and my DNS suffix. There we go. And then static IP pool. So I'm going to give the external network 10 IPs that it can use if it needs them. And vCloud Director will actually pull out those IPs and use them as needed. As something needs to acquire an IP from the pool, it can grab them. You want to make sure that nothing else can or will use these IPs other than vCloud. So for me, I have a DHCP range in the corporate LAN, which is the home lab, where there's an excluded piece of that range. So for me, it's 10.0.0.150. I'm going to give it from 150 through 10.0.0.159. So basically, it's 10 IPs that it can use to hand out to anything that needs it. It tells you at the bottom, too, that I've got 10 IPs available. So, in the format that I use, just IP start -IP end. Very simple. Click OK. Make sure to hit Add after you put the IP in there. Otherwise, when you click OK, you've basically done nothing. So here we go. We have a pool set up. Currently not used at all because nothing's grabbed one of these IPs. This is good enough for now. We don't need to build any other pools. 10 IPs should be plenty for what we're doing. If you find out later you need more, feel free to modify this and expand it or contract it if that's what you need as well. We'll click Next. We'll give it a name. So this network name is going to be what the object is referred to within vCloud. The external access is the port group name, but it's not going to be called that for the network name that we put here. So we can call this the corporate LAN. And I'll say that it connects to the official business corporate LAN, not a home lab. That way no one will know this is a home lab. And next. And here's your typical, is this what you meant to do? Review it, and then click Finish screen, in which we'll click Finish. And there we go. We have our corporate LAN that's connected to the external access vSphere port group. Now, all these names are arbitrary. You can call this whatever you want. Corporate LAN's pretty common, or LAN, because that's typically what you're connected to when you build one of these for your environment. And external access is it's neither here nor there. That's what I typically call it. You could call it the name of the subnet. You could call it your LAN. You can call it whatever you want. It really doesn't matter as long as it makes sense to you. So there we go. You've already built your external network. I mean, pat yourself on the back. That's one thing you can check off the list that you don't have to do anymore. The next thing we're going to go through is build out the 3 types of network pools that aren't VXLAN. So it's basically the port group backed networks, as well as the vCDNI network and the VLAN network. So we'll start with the port group backed. I'll click add, and here's your choices. It tells you VLAN, vCDNI. vCDNI shows up as network isolation backed here. It doesn't say vCDNI. You just have to know that network isolation backed is the vCloud Director network isolation backed, or vCDNI right there. And here's the port group backed. I kind of think that port group backed was put on the bottom because it's the one they don't want you to use, but I don't know that for sure. Also notice that it says a VXLAN network pool was automatically created. So there's not even a choice to make one because they already made one, and it can hold, like I said, thousands of networks. So there's no need to make a second one. So we'll choose port group backed here, and then next, choose the vCenter server. This one's going to be really plain Jane because there's not much to do. I've already made a port group within the vSphere environment called vCloud VLAN 30. And amazingly enough, it's also using VLAN 30. Imagine that. I'm going to add that port group to the list here. Basically, just select it, hit add. And again, it's telling you that gold will have access to this. That's fine. We'll click next. We'll give it a name. So I'm just going to call it VLAN 30 port group backed, just to make the naming easier for you. Port group backed. There we go. Next, and then finish. All right, we have our port group backed VLAN. It's currently right here. It's not used at all. None of these are going to be used right now because we haven't done anything with them yet. And also notice that the VDS shows up as just a dash because the VDS is largely irrelevant because we're using a very specific port group on a switch. It's not necessarily a distributed switch. It could be a standard switch, so they don't even put a name in here. It's just that port group. We'll go on now to the next one. Click Add. And we'll do a VLAN backed network. So it looks a little different. You notice it changes itself depending on what you're building. For this one, we'll do a VLAN range. And earlier I talked about 500 to 599. So that works. 500-599. Click Add. A little star will remind you too. And then we'll click Chicago vCenter, the vCloud distributed switch, and that's it. From there, it'll do the rest. Now, I will caution you, if you're going to build out a VLAN-backed pool, like I show you here, and you want to actually play with it in your lab, these VLANs need to be legitimate. And by that, I mean your physical switch needs to already be configured to pass traffic on these VLANs. Because vCloud Director can't go in and change the configuration on your physical switch. It doesn't have that kind of power. So these VLANs need to already be configured and basically allowed on your physical switches, or else it won't work and you'll probably scratch your head like, man, this is not working. What did I do wrong? That's pretty much what people do wrong, is they forget to actually make the VLANs. So we'll click Next, give it a name, call it VLAN backed. Doesn't matter what you call it. And I'll say, actually, I'm going to say 500 to 599 VLAN backed. VLAN backed, and then next, and finish. All right, notice with this one, it does say type is VLAN and shows you the distributed switch because it's important. It's going to build port groups on the vCloud distributed switch. So that's why it has it recorded there. Let's do the last, the vCDNI network pool, which is right here, network isolation backed. Click Next. Now, we've got number of VCD isolated networks. I'll show you something real quick. You can put in a lot of numbers and it goes red if you get too big. So when you get to 1,000, basically, it's saying no more. I won't do it. 1,001 won't do it. 1,000 works. So if you need 1,000 networks, I don't know if you do or not. Just saying, I won't judge. You can do that. We're just going to do 10 because I don't want a giant number. So the VLAN ID is basically saying what VLAN should I use under the covers on my VCDNI network. And I'm just going to use, I've got a VLAN configured VLAN 20. I'll use 20, and that's fine. Notice that there's 4,096 VLANs, but I can't use that VLAN number. I can't use 5 either. I can use 4,094, but 4,095 and 4,096 are reserved numbers, so don't try to use them. There's a couple other ones that potentially don't want to use, but those are the ones I see people hit thinking, oh, I'll just use the largest one, and it doesn't work out. So I'm going to use 20, and the same kind of process here. Choose your vCenter server, choose your distributed switch, click Next, and then we're going to do a name for it. So I can call it VLAN 20 VCDNI and VCDNI. Call it whatever you want. Next, and then finish. The names are just there to make your life easier. It has no impact on the actual program itself. Okay, so now we've built 3 different network pools. I can't claim credit for the VXLAN network pool because vCloud Director did that for me. But so you and I created 3 network pools, and we also made an external network. At this point, everything else is going to be tied into actually building out some organizations, building out some organization VDCs, and throwing some vApps in here so we can network with them. So we'll cover that in a future lesson, but now you've got all the underlying networking pools created so that you can do those activities as we move forward with the course. So I hope you enjoyed this lesson, and I look forward to seeing you in the next lesson.